welcome to Chapter 7 on environmental management, atmosphere, and the environment. So, quickly, let's move. And the first thing we need to look at here, it's the atmosphere itself. So, if you remember the word structure of the atmosphere, we need to look at the structure of the atmosphere and their individual characteristics. So, I termed them the silly monkey talks, where D represent the troposphere, silly represent the stratosphere, monkey represent the mesosphere, and talks represent the thermosphere. Now that is the four major layers of the atmosphere. So the silly monkey talks. Now what are the individual characteristics of these layers? That we have the troposphere, which is the first layer from the earth as you're moving upwards. The first layer is the troposphere. So it is the lowest and thinnest layer. It is 16 kilometers at the equator, and it is approximately 8 kilometers at poles. It contains 90% of the atmospheric mass, and temperature decreases with altitude. So the higher you go, the cooler it becomes in the troposphere. Now, it is where weather occurs. So most of your clouds and rainfall all occur within the troposphere. Now, the boundary between the troposphere and the stratosphere is known as the tropopause. Then we move from there to the stratosphere, and the stratosphere extends about 10 kilometers to 50 kilometers above ground level. So from 10 to 50 kilometers above ground level, it is less dense, so it has less water vapor, unlike the troposphere, and temperature increases with altitude. So in the stratosphere, the higher you go, the hotter it becomes, and this is caused because the stratosphere contains the ozone layer, which absorbs ultraviolet radiation from the sun. Now, so there is no weather occurrence. It contains high level of ozone layer, and the upper boundary that separates the stratosphere from the mesosphere is called the stratopause. Then from there, we'll now move to the next layer, which is the mesosphere. Now, the mesosphere extends to about 80 kilometers above the Earth's surface, and this area is where meteorites burnt up. So it contains most of the meteorites, and gases are less dense. But also in the mesosphere, the higher you go, the cooler it becomes, because temperature decreases with altitude in this mesosphere. Gases in this layer absorb very little ultraviolet radiation. So you should take note of these terms. In the troposphere, the higher you go, the cooler it becomes. In the stratosphere, the higher you go, the hotter it becomes. In the mesosphere, the higher you go, the cooler it becomes. In the thermosphere, the higher you go, the hotter it becomes. Now, the thermosphere is above the mesosphere and extends to about 600 kilometers high. Now, temperature in the thermosphere increases with altitude because it readily absorbs solar radiation. Now, temperature can go as high as 1500 degrees Celsius in the thermosphere, and it also a layer that reflects radio waves. Now, after that, the next thing we need to know is composition of the atmosphere. What is the atmosphere made up of? What are those things that if you get the atmosphere, you can separate them into those individual components? And the atmosphere is made up of gases majorly, and we have nitrogen, which accounts for 78% of the atmosphere. Oxygen accounts for 21%. We have argon that accounts for 0.9%, and other gases like carbon dioxide accounts for 0.02 to 0.03%. And we have other things like nitrous gases, methane, and ozone, and trace gases that accounts for about 1/10 tenth of 1%, sorry, of the atmosphere. So that is the composition of the atmosphere. If you are asked, is there a pie chart, you should know that it's made up of 78% nitrogen, 21% oxygen. We have argon, we have 0.03 and to 0.02% carbon dioxide. Now, let's look at the ozone layer because it's found within the stratosphere. So you see here, that's why they use the word stratospheric ozone layer. We have surface level ozone layer, which is majorly referred to as smog, which we'll look at later as atmospheric hazard. Now, in the stratospheric ozone layer, what happened is the ozone layer or ozone shield is a region of the Earth's stratosphere that absorbs most of the sun ultraviolet radiation. Now, it contains high concentration of ozone, O3. Now, in relation to other parts of the atmosphere, although still small in relation to other gases within the stratosphere. Now, the major function of the ozone layer is that it helps to absorb ultraviolet radiation. Now, if you look at this, we have ultraviolet radiation from the sun, we have ultraviolet radiation A, ultraviolet radiation B, and ultraviolet radiation C. Now, as they pass through the atmosphere and get to the stratospheric ozone layer, what happened is you find out that look at ultraviolet radiation C totally was absorbed. Ultraviolet radiation B was absorbed, but only little was able to pass through. And the same thing with ultraviolet A, though more passed through, but it was still absorbed. So it helps to reduce the ultraviolet radiation that reaches the Earth's surface. Next, let's look at the natural greenhouse effect. Natural greenhouse effect. Take notes, please, before we start. There is a difference between the natural greenhouse effect and the enhanced greenhouse effect. Enhanced greenhouse effect is atmospheric hazard, but the natural greenhouse effect occur naturally that helps to protect us from infrared radiation. No, they help to protect us from ultraviolet radiation and also help to keep the earth temperature warm for human survival. So let's look at it quickly. Now, it's a process that helps keep the Earth's surface and atmosphere warm. Now, the Earth receives incoming shortwave radiation from the sun. Now, half of this radiation is absorbed by the Earth's surface. Around 20% is absorbed by the atmosphere. Around 30% is reflected back to the atmosphere by cloud and Earth's surface back to space. Now, as the Earth's surface warms, outgoing long-wave radiation, such as infrared radiation, is a long-wave radiation, is emitted back into the atmosphere. So greenhouse gases absorb some of these radiation and deflect it back to the Earth's surface. Now, which help to keep the Earth's surface warm at night. So example of greenhouse effect, you need to know this because it comes out a lot. Just give 2-3 examples of greenhouse gases. Example of greenhouse gases. Now, it includes water vapor, carbon dioxide, ozone, methane, and nitrous oxide. These are all examples of natural greenhouse gases. Then we also have artificial greenhouse gases, which are your chlorofluorocarbons. Now, the more the concentration of the greenhouse gases, the more effectively they return radiation back to the Earth's surface, which is not always that important, because if it is more, that means the Earth temperature will increase and therefore leading to global warming and climate change. We'll look at that. That is now the impact of enhanced greenhouse effect. So, looking at this diagram here, out of the total solar radiation from the sun, you see before it reaches the Earth's surface, solar radiation is reflected by the Earth's atmosphere back. Now, most radiation is absorbed by the Earth's surface and warms it. Now, some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. Now, this effect of this warms the Earth's surface and lower the temperature. So at night, when the Earth releases this infrared radiation, which is long-wave radiation, is emitted by the Earth's surface, you find out that within the atmosphere, some are now absorbed by greenhouse gases and return back to the Earth's surface to keep the Earth's surface warm. Now, atmospheric pollution and its causes. Atmospheric pollution and its causes. Now, the first atmospheric pollution we're looking at here is smog. Now, smog is a yellowish or blackish fog formed mainly by a mixture of pollutants in the atmosphere, which consists of fine particles and a ground level ozone. Remember earlier I talked about stratospheric ozone, which is the natural occurring, and we have surface level ozone, which is the ground level ozone. It's a smog. It's air pollution. It's atmospheric pollution that leads to it. So it's caused when sunlight from the sun reacts with pollutants like nitrous oxide and volatile organic compound. Now, once they react, it will now form a brown photochemical smog known as ground level ozone. When sunlight reacts with these gases, now, burning of fossil fuel in industries, homes, and vehicles provide particles like smoke and dust for fog to form. So, this smoke and dust react with sunlight to form smog. So, we have something called the photochemical smog. It involves chemical reaction induced by sunlight on certain pollutants. Now, this reaction converts them into harmful substances like ground level or tropospheric ozone, which is known as bad ozone. Now, we'll now look at how that it's actually a hazard. Now, look at this. Now, this ground level ozone normally lead to what is known as temperature inversion. Ground level ozone. Now, in a normal condition, after the sun has hit the Earth's surface, it's expected at night that the Earth will lose heat that has been absorbed as infrared radiation back to the atmosphere. It's supposed to lose heat as infrared radiation back to the atmosphere or long wave radiation. But because of smog that has been formed or tropospheric ozone, now instead of it going back, this tropospheric ozone will now absorb this infrared long wave radiation, and it won't allow this radiation to go back out into the outer space. It will absorb it and return it back to the Earth, therefore increasing the Earth's temperature. That's it. So temperature is a weather condition when the air temperature increases with altitude. So the higher you go, the hotter it becomes because of this smog. So that's known as temperature inversion within the troposphere. Now, during the day, the surface is heated due to long wave radiation. Now, on cold and clear nights, the Earth cools very quickly, emitting radiation, therefore cooling the air above it. Now, at higher altitude, the air doesn't cool as quickly, so this air becomes warmer than the air below it. Now, this layer of warm air is the inversion layer that disrupts the regular convection current. So, and that is enhanced by smog, which is known as tropospheric ozone. Now, impact of smog. Smog affects, it has impact on human health. It causes bronchial diseases. It leads to constant asthmatic attack. It can lead to irritation of the eye and reduces visibility. Now, it leads to pulmonary diseases such as lung cancer. Now, it leads to low reduction in vitamin D, which can lead to rickets. Now, the next we'll be looking at is of atmospheric pollution and its causes is acid rain. Acid rain. We've looked at smog, and now let's look at acid rain. Now, acid rain, which is a precipitation which can be in the form of rainfall, snow, hail. So any form of precipitation with a pH value that is less than 7. Now, if you know your pH scale measures the degree of acidity or alkalinity from 1 to 14, and usually 7 is neutral, which is at the middle. So anything less than 7 is acidic, and anything greater than 7 is alkaline. So when the precipitation has a pH less than 7, then we term it to be acidic. Now, it is caused by burning of fossil fuel in factories and power station, releases sulfur dioxide and nitrous oxide into the atmosphere, and even your cars, burning of these fossil fuels using your cars also releases these gases. So industries release gases of sulfur dioxide, nitrous oxide into the atmosphere. Even volcanic eruption in this case releases this gas into the atmosphere. Now, once these gases react with water during the process of condensation, it will now form an acidic solution. So if it is sulfur dioxide react with water, it will form sulfuric acid. Nitrous oxide react with water, it will form nitric acid. And carbon dioxide react with water, form carbonic acid. Now, another thing you should know is these gases can travel long distance by wind and react with water and form this acidic rain, and it will fall back to the earth's surface in form of precipitation, but it has a lower pH because of these gases in the atmosphere. Now, what is the impact of acid rain? It leads to acidification of water bodies, which will now lead to reduction in the pH of the water, and thereby has an effect on fish population. It damages crop and vegetation, and also damage buildings. So the next hazard we look at is ozone layer depletion. The ozone layer depletion. Now, ozone layer protects the earth from the sun. The ozone layer protects the earth from the sun harmful radiation. Ozone layer protects the earth from the sun harmful radiation. Now, it is formed when oxygen filters from the top of the troposphere and react under the influence of ultraviolet radiation to form ozone. So when you have oxygen, we split first to form individual oxygen molecules, oxygen. Now, each of these oxygen can now, because of ultraviolet radiation, it can react with oxygen to now form O3, which is the ozone. These occur inside the troposphere. Now, how does ozone layer deflection occur? Now, it is continually formed and destroyed and replaced naturally, creating a dynamic balance that is disturbed by human activities. Now, human activities releases gases such as CFCs. So, when CFCs is released into the environment by industries, it rises into the stratosphere, which is the layer that contains ozone. Now, once it gets to the stratosphere, ultraviolet radiation from the sun will now break these CFCs down to release chlorine. Remember, the CFC simply means chlorofluorocarbons. Now, it will release chlorine, and the chlorine will react with oxygen in a destructive process. This chlorine will react with oxygen, chlorine react with ozone and destroy the ozone in a destructive process, breaking down the ozone molecules to chlorine, monoxide, and oxygen, thereby depleting the layers and forming a hole. Now, the hole allows harmful radiation to enter the Earth's atmosphere. Now, what are the impacts of ozone deflection? One, high level of ultraviolet radiation causes sunburns, skin cancer, retina damage, and cataracts. Extra ultraviolet radiation limits the reproduction of phytoplankton, affecting the entire food web. Now, it leads to changes in biochemical composition of some plants, thereby leaves make them less attractive as food. Next, we'll look at the atmospheric pollution and its causes. Here, we'll look at enhanced greenhouse effect. Now, enhanced greenhouse effect is created by addition of greenhouse gases to the atmosphere through human activities. So, more heat is retained in the atmosphere, and thereby it increases the temperature of the Earth's surface, leading to global warming and climate change. Now, greenhouse gases include carbon dioxide, methane, and CFCs, chlorofluorocarbons, nitrogen oxide, and tropospheric ozone. Now, this tropospheric ozone is referred to as what? Smog. Take note. We've looked at it earlier. Or surface ozone. It's the same thing as smog. Now, human activities that increases their abundance: burning of fossil fuel, deforestation, cattle and rice production increases methane, coal mine ventilation, deforestation is also, we've mentioned it. Decomposition of waste and landfill sites also lead to high level of methane. Aerosol spray, fire extinguisher, refrigerator, air conditioning, all release CFCs to the atmosphere. Then we have things like vehicle exhaust, chemical fertilizers, chemical reaction involving nitrous oxide and unburnt fuel vapors. All these lead to increase in greenhouse gases within the atmosphere. Now, what is the impact of enhanced greenhouse effect? Impact of enhanced greenhouse effect. What are the impacts? Now, it leads to climate change. climate change, which is melting of ice, sheet, glaciers, and permafrost. It leads to rise of sea level. It leads to flooding and loss of land, and it also leads to forced migration. It also leads to forced migration. Now, managing atmospheric pollution. How do we manage atmospheric pollution now? First, reduction in carbon footprint, managing of atmospheric pollution. Reduction of carbon footprint, which is a measure of the impact of our activities on the environment. Reduce use of fossil fuels. We also increase, thereby, this can be done by increasing the use of renewable energy. Energy efficiency, where you use energy efficient appliances. It also helps to reduce the emission of these greenhouse gases. We should have carbon capture and storage, where waste carbon dioxide from power station can be transported via pipelines to storage sites. Another method of managing atmospheric pollution is have a transport policies, where you create a cycle lane, bus lane, metro lane, and trams. You use electric and hybrid cars should be encouraged rather than cars that uses fossil fuels. Biofuels can be used, though biofuels also releases carbon dioxide to the atmosphere, but it's not as high as fossil fuels. Vehicles can be banned for certain part of the city, and you only use pedestrianization, where you park your cars and you use your foot to walk. Now, public transport and residential parking can be made free. If public transport is made free, it will lead to reduction in number of people that have their own personal cars. Another method is CFC replacement. We are looking at managing atmospheric pollution now. So another one is CFC replacement, where we have reduction in the use of CFCs, and CFCs can be replaced by hydrochlorofluorocarbons, can be used as alternative. Then we have taxation, higher taxes for road users, and this will decrease car ownership. We should also encourage the use of catalytic converters. So catalytic converters in vehicles reduce sulfur dioxide emission. They also convert nitrogen dioxide and carbon monoxide to carbon dioxide and nitrogen. So it reduces the impact of the emission of these gases into the atmosphere. We can also have fuel gas desulfurization. This has to do with the use of scrubbers. Can be used to remove approximately 95% of sulfur dioxide emission. Lining chimneys with lime also reduce the emission. So another thing that can be done is reforestation and afforestation should be encouraged. Now, what does it mean to encourage afforestation and reforestation? So this means reforestation has to do with replanting an area with trees, which will now help to absorb carbon dioxide. And also afforestation has to do with planting trees in barren land. All this will help to absorb carbon dioxide from the atmosphere, and thereby reducing the impact of this acid rain and greenhouse gases. Sorry. Now, reasons why acid rain, global warming affect everyone. Reasons why global warming and acid rain affect everyone. It is not just an issue that affects a small amount of the population, but it affects the whole world. Why? Now, first, gases can be moved over long distances. The atmosphere is not a barrier, so gases can move over long distance. Now, wind moves gases over long distance. So gas produced in one country can affect another country. So that's it about atmosphere. And